Colby, 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 Colby.
Okay, in this computation help video, we're going to be doing some whole number division and then discussing the remainder and what it means and different ways of showing the remainder, and then also talk about rounding to specific place values when we express our quotient as a decimal. We're going to work on this problem 1,582 divided by 24, which could also be shown this way, already set up as long division. Our dividend is 1,582, our divisor is 24, or it can also be, we can also express division in fraction form. The vinculum indicates division, and here again we have 1,582 divided by 24. And I want to talk about the fraction form for a minute, because as we're working towards more and more advanced math, we're going to favor this fraction form for a lot of different reasons. But let's take a simpler division problem like 12 divided by 3, or 12 thirds. If we're dividing by 3, we're counting thirds. Here we're dividing by 24, we're counting 24ths, whether we show it this way, or this way. If I have 12 thirds, I have 12 1/3. Dividing is the same as multiplying by the reciprocal, so dividing by 3 is the same as multiplying by 1/3. And then if you think of 12, or if you substitute 12 as 4 of 3, then you have 4 of 3 of a third. You can then associate the 3 multiplied by 1/3 and express it this way: 4 multiplied by 3/3. We know 3/3 is 1 whole, so our quotient is 4. I mention that because we're gonna come back to this idea when we talk about the remainder. But anytime you're dividing, you're just multiplying by the reciprocal. That's why we show it in fraction form often. Okay, so if we have 1,582 divided by 24, I'm wishing I would have put some graph paper on this slide, because you'll notice that on your computation sheets I have a background of light blue graph paper, and the reason for that is to line up your place values. So you use that to your advantage, because it's very easy to misplace a digit when you're doing long division. When we're doing long division, I don't want to make this video overly long, but we'll talk in class about why long division works and what it means conceptually. Here we start by saying how many 24s are in 1, and of course there are 0 24s in 1. How many 24s are in 15? There are 0 24s in 15. How many 24s are now in 158? Well, if I think about 25, I could get 4 25s in 100 and 2 more 25s in 50. So I'm going to try 6 first. Off this side here, I'll do 24 multiplied by 6. 4 times 6 is 24, carry the 2. 2 6s is 12, and 2 is 14. So 144 is pretty close to 158. If I added another 24, I'd go over, so 6 is the correct choice here. 6 24s is 144. Now the reason long division the algorithm works, but really we want to know how many 60s are in 1,580. If you really think about place value, you'd think about it differently, but we can get into that in another time. But 8 minus 4 is 4, 5 minus 4 is 1. And anytime you're dividing, remember we said we're counting, if we're dividing by 24, we're counting 24ths. This difference should be less than 24. If this was 24, then we'd have another whole here. We'd have 7 instead of 6. Or if it was more than 24, we could increase this number. So that difference should always be less than whatever your divisor is. And then we can bring down this 2, and we can ask how many 24s are 142. We know 6 was 2 too many, because that's 144, so we use 5 here. 5 20s is 100, and 5 4s is 20, so this is 120. And our difference here is pretty easy to see, it's 22. So, one way to write this, and the way I'm going to ask you not to write it anymore if you do it this way, is 65 remainder 22. And the reason I don't want us to write it that way anymore is because what does that mean, remainder 22? 22 what? I know this is 65 wholes, but what is this, 22 what? Well, if we're dividing by 24, we're counting 24ths. And so if you have a remainder of 22, that means you have 65 and 20. You know what? That was a bad place to put that. You'll see why in a minute. If we're counting 24ths, this is 65 and 22 24ths. And then of course we would simplify our fraction. So 22 24ths is equal to 22 is 2 11s, 24 is 2 12s, and then we can factor out this 2 halves because that's one whole. We'd have 65 and 11 twelfths. That's a fine way to express that quotient. On your computation sheets, often I will ask you to express it as a decimal and round to a specific place value. So let's pretend that was the situation here. If we want to keep dividing, we need to show our decimal. If the decimal is not in sight, it's on the right. If this is a whole number, we show the decimal here and put a 0 in the tenths place. Because if we had 1,582 wholes, we have 1,582 wholes and 0 tenths. And we also have 0 hundredths and 0 thousandths. So we don't show those zeros, but we can show them. It doesn't change the value. And once we show that decimal, we should line it up in our quotient. So then we can bring this 0 down and ask how many 24s in 220. Let's see. 10. Well, obviously 10 is not going to work because we have a room for one digit. But 9 24s would be 180 and 36 is 216. So this must be 9. 9 times 20 is 180. 9 times 4 is 36. 180 and 36 is 216. Subtract and we get a difference here of 4. We can show the 0 in the hundredths place. Bring that down. And there's 124 in 40. Subtract and we get 16 here. I'm going to erase this. And show the 0 in the thousandths place. Bring that down. How many 24s in 160? 6, because 24 added to this would be over 160. So 6 24s. 6 20s is 120. Well, we already know that, don't we? 144 right here. And then I get a difference of 16. We had a difference of 16 here and 16 here, so we're going to keep getting 6's here. So we're going to talk a lot about rational numbers and what that means in class. But if you have a number, or if you have a number that can be written as a fraction, and clearly this can because you see it right here written as a fraction, then it's going to either be a whole number or a terminating decimal or a repeating decimal. And so in this case we have this repeating decimal, the 6 repeats. So one way to write this is 65.916 and the 6 repeats. One of the things that I ask you to do on these computation sheets for these type of problems is to round your quotient to a specified place value. So I want to imagine that we want to round this number to the tenths place. First we identify the digit in the tenths place, which is the 9. Look at the digit to the right of that. The next lowest place value is a 1. And so if this number to the right were 5 or more, we would round up this 9. But if it's less than 5, then we just end the number in the tenths place without rounding that digit up. So 65 and 9/10 would be our value rounded to the tenths place. If we look at this on a number line, we can see what rounding really is. If we're rounding to the tenths place, we want to know which 2/10 this number is in between, and of those 2/10, which one is it closest to. Here's 65 and 9/10, and here's 65 and 10/10 would be 66 and 0/10. And our number is right about, I'm going to say right about here. 65.916 repeating is right about there. So what's the halfway point? The halfway point would be 65 and 9.5 tenths, which would be 95 hundredths. If I create like terms here by showing the digit in the hundredths place, we have 65 and 90 hundredths, 66 and 0 hundredths. This is 65 and a little more than 91 hundredths, but it's definitely closer to 65 and 90 hundredths or 65 and 9 tenths, so that's why we rounded it to 65.9. If we take this same number, 65.916 repeating, and now we round to the thousandths place, we would first identify the number in the thousandths place. This is the tenths, hundredths, thousandths place, and then look at the digit to the right of it and the next lowest place value, the 10 thousandths place. And this time it is 5 or more, it's 6. And so we're more than halfway to the next thousandth, and so we should round this 6 thousandths up to 7 thousandths. So 65 and 917 thousandths would be this value rounded to the thousandths place. Okay, I hope that helped with whole number division, long division, and understanding remainders, and also with rounding to specified place values. If you're watching this video, good job, because it means you're doing the extra work to get better at these types of exercises. And there are practice pages down below the video, so you can pick the topic that you need the practice on. You can print that page, try some exercises, and then check yourself with the key. Thank you for being an excellent student, putting in the extra work, and I hope this helped, and I'll see you soon.